Have you ever wondered what happened before everything existed? Our story begins not with a whimper, but with an immense burst of energy known as the Big Bang. This extraordinary occurrence is the widely accepted explanation for the birth of the universe. And it happened nearly 13.8 billion years ago. Imagine, if you will, all the matter, energy, space and time in the universe compressed into an infinitely small, dense and hot point. Then in less than a blink of an eye, this point exploded. This wasn't an explosion in the conventional sense. No, it was an explosion of everything, everywhere. In the immediate aftermath of the Big Bang, the universe was an incredibly hot, dense sea of particles and energy. It was so hot, in fact, that particles of matter and antimatter were continuously being created and annihilated. This tumultuous period lasted for a fraction of a second, but had profound implications for the universe we live in today. As the universe expanded, it also cooled. From this cooling, the first atoms began to form about 375,000 years after the Big Bang. These were hydrogen and helium atoms, the simplest elements in the universe. And with the formation of these atoms, the universe underwent another dramatic transformation, the birth of light. Before this point, the universe was a murky soup, too dense for light to travel. But as atoms formed, the universe became transparent, allowing light to travel freely for the first time. This light, the afterglow of the Big Bang, is still detectable today. It's known as the cosmic microwave background, a faint echo from the dawn of the universe. So that's how it all began. From a single point of fiery, dense matter, the universe as we know it began its journey. And what a journey it has been, and continues to be, as we'll explore in the upcoming scenes. But for now, just ponder this. Every atom in your body, every star in the sky, every galaxy in the cosmos, all of it began with a bang. From a single point of fiery, dense matter, the universe as we know it began its journey. So, how did we go from a hot, dense universe to the galaxies we see today? Well, it all started with clouds of gas and dust floating in the vast expanse of the universe. These clouds of gas were primarily composed of hydrogen, the simplest and most abundant element in the universe. In the early stages of the universe, these clouds of gas were scattered, dispersed, and seemingly unconnected. Yet gravity, the cosmic glue, began to pull these seemingly separate particles together. Over millions and millions of years, these particles, under the relentless pull of gravity, began to form clumps. These clumps of gas and dust grew denser and denser, hotter and hotter, until finally the pressure was so great that nuclear fusion ignited. This process formed the first stars. Over time, gravity continued its work, pulling these stars together into clusters. These clusters gradually merged and formed galaxies. But not all galaxies are the same. There are three main types of galaxies: spiral, elliptical, and irregular. First up, we have spiral galaxies. These galaxies have a flat, rotating disk containing stars, gas, and dust, with a central concentration of stars known as the bulge. These are surrounded by a much fainter halo of stars, many of which reside in globular clusters. Next, we have elliptical galaxies. These galaxies are generally round, but can stretch longer along one axis than along the other, making them appear elliptical, hence the name. They are filled with old stars and contain little dust and other interstellar matter. Lastly, we have irregular galaxies. These galaxies do not fit into the spiral or elliptical categories. They have no regular or symmetrical structure. They are often chaotic in appearance, with neither a central bulge nor spiral arms. The galaxies, with their billions of stars, are the building blocks of the universe. Each one is a testament to the power of gravity and the beauty of cosmic evolution. From clouds of gas and dust to the intricate structures we see today, the formation of galaxies is a story of creation on a cosmic scale. The galaxies, with their billions of stars, are the building blocks of the universe. In the vast expanse of the universe, where does our own solar system fit in? Let's dive into this cosmic conundrum and unravel the mysteries of our cosmic neighborhood. The Milky Way, our home galaxy, is a colossal spiral of stars, gas, and dust. It's a grand cosmic city home to hundreds of billions of stars, each with their own planetary systems. It's within this galactic metropolis that we find our solar system, a modest neighborhood tucked away in one of the Milky Way's spiral arms. Our solar system emerged around 4.5 billion years ago from a cloud of gas and dust, a nebula. As this nebula collapsed under its own gravity, it began to spin, forming a disk. At the center of this disk, our sun was born, a fiery furnace fueled by nuclear fusion. Around this young star, the remainder of the nebula continued to swirl, gradually forming the planets, moons, asteroids, and comets we know today. This process, known as planetary accretion, gave birth to our solar system's diverse cast of celestial bodies, from the gas giants Jupiter and Saturn to rocky planets like Earth and Mars, and icy bodies in the outer reaches. But let's put things into perspective. Our solar system, spanning over 7 billion miles from the Sun to the outer edge of the Oort cloud, is but a tiny speck in the vastness of the Milky Way. The Milky Way, in turn, is just one among billions of galaxies scattered across the universe. Yet, despite its relative smallness, our solar system holds a unique place in the cosmos. It's here, on our home planet Earth, that we find the only known life in the universe. It's here that we gaze out into the cosmos, seeking to understand our place within it. So, where does our solar system fit in the universe? It's a small part of the Milky Way, which is just one galaxy among billions. But remember, size isn't everything. Our solar system, while just a small part of the universe, is our home in the cosmos. In the vastness of the universe, is Earth the only planet that harbors life? This question has intrigued and bewildered humanity for centuries. As we delve into the conditions that make Earth unique, we will find that it's a perfect cosmic recipe for life to evolve. Earth is nestled in the habitable zone, a region around a star where conditions are just right. It's not too hot, not too cold, but just right for liquid water to exist, a crucial element for life as we understand it. Our planet's magnetic field protects us from harmful solar radiation. Without it, life on the surface would be exposed to lethal levels of radiation. This invisible shield, generated by the churning of molten iron in Earth's outer core, is another key ingredient in our planet's life-sustaining recipe. Earth's atmosphere, a delicate blend of nitrogen, oxygen, and trace amounts of other gases, provides the air we breathe and regulates our planet's temperature. This atmospheric cocktail, together with the presence of water, makes Earth a veritable oasis in the cosmic desert. But is Earth truly unique? The search for life beyond our planet is one of the most exciting frontiers of science. Astrobiology, the study of life in the universe, has made significant strides in recent years. The discovery of exoplanets, planets beyond our solar system, has opened up new possibilities. Some of these distant worlds reside in their star's habitable zone, raising the tantalizing prospect that they could harbor conditions suitable for life. Rovers and spacecraft are probing Mars and other celestial bodies for signs of past or present life. Even the icy moons of Jupiter and Saturn, with their subsurface oceans, are considered potential abodes for extraterrestrial life. In this vast cosmic arena, the possibility of life existing elsewhere is too compelling to ignore. While Earth is currently the only known planet with life, the search for other life-bearing worlds continues. It's a quest that speaks to our innate curiosity and our desire to understand our place in the universe. While Earth is currently the only known planet with life, the search for other life-bearing worlds continues. We've traveled from the birth of the universe to the present, but what about the future? As we peer into the cosmic abyss, we must question what lies ahead in the grand cosmic narrative. The first theory we'll delve into is the Big Freeze. This scenario paints a chilling picture of a universe slowly cooling as it expands. As galaxies drift apart, the stars within them will eventually burn out, leaving behind a dark, cold universe. Next, we have the Big Rip theory. This is a rather dramatic concept where the universe doesn't just cool and fade, but it literally tears itself apart. Imagine this: the universe's expansion, driven by a mysterious force known as dark energy, accelerates to such an extent that it eventually rips galaxies, stars, and even atoms apart. Then there's the Big Crunch theory. This is essentially the reverse of the Big Bang. It suggests that at some point the universe's expansion will slow, stop, and then reverse. Galaxies would rush back together and the universe would become denser and hotter, ultimately collapsing in a fiery singularity. Each of these theories is based on our understanding of dark matter and dark energy, two elusive entities that make up about 95% of the universe. Dark matter, with its gravitational pull, is thought to be a key player in galaxy formation, while dark energy appears to be driving the universe's accelerated expansion. However, let's remember that these are all theories. The future of our universe is still shrouded in mystery. Our understanding of dark matter and dark energy is still in its infancy, and new discoveries could lead us to revise or even discard these theories. What we can be certain of is this: our quest for knowledge is relentless. Scientists around the world continue to explore, to question, to dream, and to discover. They're peering deeper into the cosmos, seeking answers to questions that have captivated humanity for centuries. Though the future of the universe is uncertain, the journey of discovery is never-ending.